Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge or the challenge number 83 called the remove duplicates from sorted list. And for this particular challenge, given the head of a sorted list, delete all duplicates which such that each element appears only once, and then return the linked list sorted as well. And for the example right here, example number 1, we have node 1 that chain with the node 1 and also chain with node 2 as detail of the node, and we return only the node 1 and 2 because it only contains the node chain only contains the unique values instead of the duplicates value from the node 1. And that way we are either removing the first node as the duplicate one or the second node as the duplicate one. But as we need to iterate over the linked list node, or especially as linked list, then we need to use the latter one, which is the middle one, and we remove the middle one and we rechain the node 1 dot next with the node 2 with the node 1 dot next and then dot next again, as I say of the next property 2 times, and I will explain to you later after this. Okay, so what about the input head? We have the 1 1 2 and then the output is only 1 and 2. And for the example number 2 right here, we have only node chain of 1 1 2 3 and 3. Okay, so the first one we assign this as the unique node, and the second one, which is not unique, which is the duplicate from the first one, then we need to eliminate the second node from our list, and that way we are assigning the node 1 dot next, assigning to the with the duplicates dot next, and we are assigning next equals using the next dot next, because as you know, a linked list, which using the class right here, definition of linked list, we have the node that consists of the property of file of the value, and then the next either list node, another list node, or null. Since next property can be accessed, then with the another list node it is possible, then the list node is also contains the same class using the reusable class of the list node right here of the definition. Then we can also access the its next property after the next property, so we are chaining the next property and then next property again. So that is the neat thing of using the linked list. Okay, so for another one, we are chaining 1 with 2. We already chained that, and since 2 is unique, then we need to chain 2, and then we are chaining the 2 with 3, of course, because they are both unique and not the same. And the last one, which is the duplicates from the previous one, then we need to eliminate this one, and that way the node 3 of this part of the tree using the next property, which is equals to null. That is the next property right here, should be null. Then we are only have the node 1, node 2 and node 3 chained with the null, the next node. Okay, so what about the constraints? Yep, we have the number of nodes. It is possible that the number of nodes in the list is in the range of 0 to 300. So this one, from this part of the node, that of the example 2, we have 5 nodes, which is on the range of 5. Then for the first example, we have the range of 3. As you know that we can read as 1, 1 and 2, and we have 3 nodes at total, and it is possible to be the nodes is possible to be 0 or up until 300 inclusively. So what it means by 0, that the node is possible, that the head node possible to be null. Then since we are using TypeScript, if you want to use something else other than TypeScript, then go ahead. But since we are using TypeScript, then we need to add an edge case to check if the head property or the head parameter, the head parameter is already null. If it is null, then we return the null instead of the list node, because the property right here, head property right here, it is possible to be a list node, either list node or null, using the single pipe notation right here. And the expected output is also in the form of list node, either list node or null. And the function itself, which is called the delete duplicates, that only takes one parameter. Okay, so using the if if the head is equals to null using since we are using TypeScript or JavaScript, then we can use the exclamation mark or exclamation sign in front of the head parameter. That way we are signifying that the head, if the head is null, then we return null right away. That is the first edge case to be considered. Okay, so the second constraint, we have the node value that inclusive between -100 or -100, and the max value should be 100 at max, and they are both inclusive from -100 to 100. What it means by inclusive, the inclusive would be this 100 will be also included, and also the -100 is possible to be also included in the node data or the node dot value, and the list is guaranteed to be sorted in ascending order. What it means by ascending order, so it means that we are starting from the least value up to the point to the highest value, which is in a form of sorted ascending order. So how do we solve this out? The first way, I'm going to introduce you the first way using the set to. First, we are using the example one right here, that we are iterating over the node chain right here and check if the value of the thing that we iterate is the unique or not. Hence, we are using the set variable and the set data type. And after that, we need to iterate over the set, and we construct new node as the whole new node. And the second way is by using the current iteration or the iterator of the existing head node to check, like I described from the first. Let me visualize this for a moment. I'm using the red color, and we have the one with the one right here. We can add a check if both nodes, if both nodes right here of the current iteration, they are both not null, so it contains the node. Check if they are both contains node, then check if the current value is equals to the next of the value property using the next and then dot fall. Comparing both of them, if they are the same, then of course we need to skip this one, and we can just jump to the next property using accessing the next property of the one that we should delete, and that way we're assigning the next property of the current iteration with the next property of the second iteration or the second node that should be eliminated, and that way we are ultimately skipping the second one as from the node chain, and then we are just directly assigning the one dot next using the node 2 as the next property of the one right here. Okay, so let me practice on the first approach using the set. We need to declare the set using the constant mySet or the unique set, unique values called the new set constructor, and we are constructing new set as the unique values variable. And that way, since we are using TypeScript, then we need to declare the set property of the data type. We have only one value, and the type should be a number. That way we are declaring the set like this. We have the set, and we are assigning either 1, either 2, and then either 3. Not able to store any duplicates value after that. So that is the neat thing about using the set. Okay, so what about iterating over the linked list right here? We need to declare a while loop. Before we declare the while loop, we need to declare the head as the iterator using the let or the constant. Let me use constant variable, constant of the current using the head, and that way we are assigning the current as the iterator of the head that traverses over the head node, over the next again, over the next again. And we can check as long as the current is not null using the exclamation mark in front of it, then we are assigning the current equals the current dot next. But before we are moving to the next iteration, that we need to console.log of the current dot value, and that way we are assigning the its value property of the current node. And as we as we iterate and we read the value, after that we need to assign the current using the current dot next, and that way we are moving to the next node of the existing node chain. Okay, so let's return null for now, and let's run this to see what the debug log is about. And we have the cannot assign current because it is a constant. So since the current variable is a constant, then we need to change this to let variable type instead. And we got the output, which is equals to null, that we already defined right here as the placeholder, and the expected is 1 and 2. Okay, so what about the console.log? It is not being logged properly. Check if the current is not equals to null, then we run this. And yep, we have the standard output of 1, 1 and 2 as we iterate over the head nodes using the current iterator, and that way we get the sequence of the while loop sequence right here. So how do we assign this? How do we assign the unique values from the current node as we iterate over the current node chain right here? So it is fairly easy. We need to use the unique values, and then add in the add method, and we are accessing the current dot value to be added inside the unique values set number. And after that, we need to console.log the unique values to see what is inside the set. So let's run this again, and we have only two sets of 1 and 2 instead of the duplicates value, and it's only assigning the unique values. What about the case 2 right here? We have set 3, 1, 2 and 3, and the expected output is also 1, 2 and 3. So we have a good start right here, and that way we only need to iterate over the unique values, and we assign this to a new constructor of the node chain class of the list node right here, of the singly linked list. So how do we do that? Is by using the unique values dot for each of the value, and I'm using the arrow sign, and to define the parameter of the for each only takes one parameter, which is the value itself, and we are using the curly brackets after the arrow sign, and we need to press enter, and that way we are using the console.log of the value of the unique values, and that way we are iterating each of the unique values inside the unique values set. So let's run this again, and we have still wrong answer. We have on the output of 1 and 2. Okay, we have good start right here. Instead of printing the set data type, then we print the value right away. So how do we assign this as the new node? Okay, so before that we need to declare a new node called the constant new node, and we need declare a new list node, and that way we are assigning 0 as our dummy node, and we are returning the new node. Why should be a dummy value of 0? Is because in order to get the next property of the new node that we already construct, then of course we need the first value to be 0, and that way we are skipping this one, and we can just use the new node dot next instead to shift this by 1 instead of printing the 0. And the next one should be using the constant of the iterator, and we assign the new node, and the iterator constant, should be using the let property of let variable instead of the constant variable, and the iterator acts as the iterator to iterate over the new node chain and traverse over the new node and assigning the next property of the new node. So what happens if we just insert the new node and assigning the next property, and we are using the new list node of the value, and then we use the new node equals new node dot next, and we return the new node right away. So let's run this to see what went wrong. Cannot assign new node because it is a constant. Okay, what about using the let? Let's run this again, and we only have the output of 2 instead of 1 and 2. And the case 2 right here, we only storing the very last value of the output instead of the whole unique node chain. So how do we get around this? Is by using the iterator instead of the new node constructor right here. Let's change this back to the constant variable, and we use the iterator instead of the new node variable to iterate over the new node, and we use the iterator dot next and use new list node of the value, and we are assigning iterator equals the iterator dot next, and we return new node instead, and we have 0, 1 and 2, and the case 2 should be 1, 2 and 3. So that is the main thing. The 0 is also being printed because 0 is supposed to be the dummy node. How do we get rid of the 0 of the node? It is very easy. We can just assign the new node dot next instead, and that way we are assessing only the next property of the new list node of 0 value. So let's run this again to see if it works, and we have the accepted answer. How do we submit? How about submitting the code? And we bound to have the runtime of 1 millisecond and the memory complexity that is 58. So if you want to stop the video right here, then go ahead, but I will show you the most effective way. Instead of using the 2 passes right here, see the first one, we iterate over the first one to check, and assigning the unique values is in the set, declaring a new set variable that takes up the memory right here, memory complexity, and also the second pass, which is the creating a new node iterator that also takes up the memory and also the iterator, and that way we are iterating over the set to assign the new node chain to the next one we construct, and we build up from the scratch from the second pass, and we are returning the next right away. So the since we have 2 passes, then the runtime will be 1 to 5 milliseconds because it takes 2 phases to process the code. Okay, so how do we use or are we going to use the most effective way to solve this out? Like I said from earlier, we can just use the next property using the next.next again to check if both nodes are not equal to null, then we can just compare both nodes. If they are both the same value, then we need to skip the next one, and we can just assign the next one or the next node. Okay, so let's comment this out, and we can just keep using the edge case right here because it is possible that the head is null. So about this constraint range right here. Okay, how do we do this? We can use first check the while loop, but before that we need to declare the current node again, as the iterator to iterate over the head node using the current, using the while. If the current is not equals to null, and also the current dot next, which is the one right here, and the next property, which is the one right here of the second node of the first iteration of the current, check if the current dot next is also not equals to null. As long as both are not null, then we need to do the operation. We can check if the current dot value is strictly equals to the current dot next dot value, and that way we are accessing the current dot value, which is right here, this part, current dot value, and the next one, which is the current dot next. This one is next dot next, and then dot value. That way we are assigning both next property, which is this arrow sign, which points to the next node, and then dot value, which is the value of the next. Check if they are both equal. Since they are both equals, then we need to eliminate this part, and we can just assign the current dot next using the next arrow right here, and we are assigning the next dot next. We are assigning the first next, and then we are assigning the second next dot next again. We are assigning this part of the next as the arrow sign, and that way we are skipping the second one. Instead of deleting the second one, we can just skip it right away, and that arrow will points to the value of a node. Okay, so let's use the if check. If the current dot value is strictly equals to the current next value, if it is, then we need to assign the current dot next with the current dot next. Since current dot next is points to the second one, then we need to use the second next to access the next property of the second node. That way we are mutating the second next as the first next. How do we do this? Is by using the current dot next and then dot next again, as simple as that. And we can use the else check. Else, if it is not, if they are both unique, then we can just move to the next one. Let's say on the first one right here, the example number 2, we have the first iteration of the current checking if they are both true. Since they are both true, then we need to skip this part, and we are assigning the current dot next equals current dot next and dot next again, and then we are moving the second iteration using since the current dot next is already assigned to the node 2 right here. Then we check if they are both using the while loop. They are both not equals to null, then 2 and 3 exists. 2 and 3 are both exists. Then checking if they are both the same, the value are the same. Then if it is not, then we can just assign in the current equals the current dot next, and that way we are moving to the next part of the iteration of the current iteration using the 3 right here, and checking if the value is equals to the current dot next dot value. Since they are both the same, then of course we are assigning the current dot next using the next using the 3 right here, pointing to the next. Since pointing to the next is equals to null, then we are assigning the next equals to null, just like this one, and that way we are assigning 3 as the null. Okay, so that is the rough explanation, and we can just assign the current equals the current dot next right away, and we can just return our current, not returning the current but returning our head instead. And let's run this out again to see if it works, and we have the accepted answer. How about we submit this and check it to see if we have any difference. Looks like it is still the same, but at least we are using both methods to iterate over the node chain, and we have 2 solutions from just one challenge of the challenge number 83, remove duplicates from the sorted list. So look, we have 0 millisecond of the runtime and the memory complexity of the 58. So that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.